Hello guys, so welcome back to the channel and welcome back to Excel Island, where the goal on the day save is to learn and master Python over the next 100 days. And today is day 67. We are going to continue from where we stopped on day 66. We are on the course called Exploratory Data Analysis in Python, where we are learning how to explore and visualize, analyze, and get to know your data set. So the first chapter that we completed on day 66 was getting to know a data set, like what are the first things you need to do when you have access or you inherit a new data set rather. So on the last live stream, a couple of two live streams ago, we learned to validate and summarize categorical and numerical data sets and create simple visualizations to communicate our findings. So on today's live stream, we're going to start the chapter 2 of this course, which is exploratory data analysis. It actually contains 4 chapters. We are on the second chapter, starting the second chapter out of the 4 chapters first today. We are going to be learning data cleaning and imputation method. We are going to be exploring analyzing data, often means dealing with missing values. We're going to learn how to correct incorrect data types and outliers. So in this chapter, you learn techniques to handle these situations and streamline your ADA process. So let's get started. Without further ado, let's jump back to the learning. So, all the goal of this chapter is to learn how to clean data, what to do with missing data and missing values, and incorrect data types and outliers within your data set. And I believe this knowledge can be used across multiple tools like Power BI, Excel, SQL, and so on. So, let's find out. So, I'll just start sharing my screen real quick so we can continue from where we stopped on day 66. Okay. So this was the last lesson we completed just 24 hours ago, definitely a day ago, where we looked at group by, count, standard deviation, and all the summary statistics or function you need to know in Python. So,
Hi, I'm George, and in this video
hold on a minute. Let me just change my microphone.
we'll look at strategies for handling missing data. So, why is it important to deal with missing data? Well, it can affect distributions. As an example, we collect the heights of students at a high school. If we fail to collect the heights of the older students, who were taller than most of our sample, then our sample mean will be lower than the population mean. Put another way, our data is less representative of the underlying population. In this case, parts of our population aren't proportionally represented. This misrepresentation can lead us to draw incorrect conclusions, like thinking that, on average, students are shorter than they really are. Let's illustrate how missing data impacts exploratory analysis using a dataset about data professionals. This dataset includes the year the data was obtained, job title, experience level, type of employment, location, company size, time spent working remotely, and salary in US dollars. To highlight the impact of missing values, let's look at salaries by experience level using a full version of the dataset. Now, let's compare this to the same data with some missing values. The y-axis shows that the largest salary is around $150,000 less in the second plot. With our dataset stored as a pandas data frame called salaries, we can count the number of missing values per column by chaining the .isNA and .sum methods. IsNA refers to the fact that missing values are represented as NA in data frames. The output shows all columns contain missing values, with salary USD missing 60 values. There are various approaches to handle missing data. One rule of thumb is to remove observations if they amount to 5% or less of all values. If we have more missing values, instead of dropping them, we can replace them with a summary statistic, like the mean, median, or mode, depending on the context. This is known as imputation. Alternatively, we can impute by subgroups. We saw that median salary varies by experience, so we could impute different salaries depending on experience. To calculate our missing values threshold, we multiply the length of our data frame by 5%, giving us an upper limit of 30. We can use Boolean indexing to filter for columns with missing values less than or equal to this threshold, storing them as a variable called cols to drop. Printing cols to drop shows 4 columns. We drop missing values by calling .dropNA, passing cols to drop to the subset argument. We set inPlace to true, so the data frame is updated. We then filter for the remaining columns with missing values, giving us 4 columns. To impute the mode for the first,
Hold on a minute. I'm lost there. Let's go back a little bit. Sorry about that.
there are various approaches to handle missing data. One rule of thumb is to remove observations if they amount to 5% or less of all values. If we have more missing values, instead of dropping them, we can replace them with a summary statistic, like the mean, median, or mode, depending on the context. This is known as imputation. Alternatively, we can impute by subgroups. We saw that median salary varies by experience, so we could impute different salaries depending on experience. To calculate our missing values threshold, we multiply the length of our data frame by 5%, giving us an upper limit of 30. We can use Boolean indexing to filter for columns with missing values less than or equal to this threshold, storing them as a variable called cols to drop. Printing cols to drop shows 4 columns. We drop missing values by calling .dropNA, passing cols to drop to the subset argument. We set inPlace to true, so the data frame is updated. We then filter for the remaining columns with missing values, giving us 4 columns. To impute the mode for the first 3 columns, we loop through them and call the .fillNA method, passing the respective column's mode and indexing the first item, which contains the mode, in square brackets. Checking for missing values again, we see salary USD is now the only column with missing values, and the volume has changed from 60 missing values to 41. This is because some rows may have contained missing values for our subset columns as well as salary, so they were dropped. We'll impute median salary by experience level by grouping salaries by experience and calculating the median. We use the .toDict method, storing the group's data as a dictionary. Printing the dictionary returns the median salary for each experience level, with executives earning the big bucks. We then impute using the .fillNA method, providing the experience column and calling the .map method, inside which we pass the salaries dictionary. Now we see there are no more missing values. Let's practice working with missing data.
Oh, this is quite technical. You have to be pretty careful here. Okay, let's give it a shot. Nothing is really hard until you try. Also, I have to create a new Jupyter notebook file. This was the last one we used for the getting to know your data sets, either in Python, which is the first chapter that we covered in this exploratory data analysis. So let's continue. It says dealing with missing data. It is important to deal with missing data before starting your analysis. One approach is to drop missing value if they account for a small proportion, typically 5% of a data set. Oh, cool. So if the missing value is less than 5%, probably above, hmm, we won't say above 5%. Typically, if they are 5% of a data set, you can just drop them. So the second approach, working with a data set on a plain ticket price stored as a pandas data frame called plains, you will need to count the number of missing values across all columns, calculate 5% of all the values, Use this threshold to remove observation and check how many missing values remain in the data set. Interesting. So the data set will be linked under due to description, which is the plain data set or the data set that we've been using so far, under due to description. So you can just download them and also use it to get your hands dirty. So let me just connect to the plain data sets in my Jupyter notebook here, real quick. So let's create a new file. Okay, a new notebook. I'll just call this new notebook data cleaning and importation. I'm just going to call this one EDA day 2. Let me just name it like that. So it will be easy for me to track. You can see EDA in Python. Okay, day 2. Let me rename it better. Let's refresh. EDA in Python, EDA in Python 2. That is better. So I just go ahead and copy all these my libraries that we always use. I run the line of code. Then we need to call on this, my read plain data set here. So our data set for now is plains. I'm just going to change this to plains so I can see the paths in my local machine here. I'm just going to change this one to this last part here. Don't worry about this. I'm having a challenge with my Jupyter notebook currently right now. So that's why I'm using this long line of code to connect to the data sets. So if I call on plains now, dot head, you can see what our data set looks like. So this is the plain data sets. We have the airline, the dates of journey, the source, the destination. We have the route, the departments, departure time, arrival time, duration, total stops, additional info, and the price of each flight. Let me just switch on my camera real quick there. You can see the price of each flight. Interesting. If I run this code, see the data set is over 10,000 rows of data with 11 columns. Let's just do dot head. For starters, so interesting. So that is that. So we have our data sets already launched in Jupyter Notebook. So let's see what we need to do here. Print out the number of missing values in each column of the data frame. So to do that, we're just going to use the isNA method. It's going to be plains.isNA dot sum. Let's see the number of missing values we have here. Ooh, these are quite a lot. Let's see here also. So for this column, we have over 400 missing values, quite a lot of missing values. Ooh, I think the price column has the highest number of missing values, which is 616. Okay, let's see what we can do with this information. Calculate how many observation 5% of the plane's data frame is equal to. Going to calculate how many observation of 5% the data frame is equals to. Find the 5% threshold. So it says here, it's a one approach is to drop missing values if they account for a small proportion, typically 5%. We're merely looking at the information we have right now. We could say they are above or more than 5%. Okay, now let's see. We're going to use this code called len, then the data frame. It's the plain data frame, multiplied by 0.05. That gives us 5%. Mm. So we need to print, I cannot say it should print threshold. Let's see. You can see over, this is giving us 533, which is above 5%. Let me see this. Let's use this in my Jupyter notebook here. You see, this is like 53%, which is way, way higher. Way, way too much. Let's submit and see. Okay, create the cost to drop by applying Boolean indexing to columns to the data frame with missing values less than or equal to the threshold. Use this filter to remove missing values and save the updated data frame. It says create a data frame called columns to drop. So we want to drop some columns. We want to apply Boolean indexing to the columns of the data frame with missing values less than or less than or equal to the threshold. So cost to drop. Okay, let's come back here. Create a filter. Column to drop is going to be the plain data frame dot columns. So the columns are going to be from the plain data frame also. Plains. Plains dot is na dot sum. Then the threshold. I'm going to point to this threshold that we have here. Sorry about that. So we've created a filter. So this is our filter line of code that now says drop missing values for columns below the threshold. This will be plains dot drop na subsets of the columns to drop data frame. Then we set in place to 2. In place to 2. Okay, let's run the line of code and see. Voila. You can see now the missing values can be dropped in starting columns, but these columns have more missing values. Let's take a look at this in Jupyter Notebook. Let's see it in action here. This is the filter. Let's do it one at a time. So the filter have been called upon. Drop missing values for columns below the threshold. We've done that. If we print plains.isNA now, we're going to see something different from the initial that we have here. So the missing values have been dropped in this column, except this additional info and price column. Then probably we're going to replace this additional info and price column with the median of the data that we have in those columns. Interesting. Okay, let's submit and see. Awesome. So by creating a missing value threshold and using it to filter columns, you've managed to remove missing values from all columns except for additional info and price. Okay. So we have managed to remove the missing values for all columns except for this additional info and price column. So what do we do then? Strategies for remaining missing value data. The 5% rule has worked nicely for your plains data sets, eliminating missing values from 9 out of 11 columns. Now you need to decide what to do with the additional info and price column, which are missing 300 and 368 values. Interesting. So this is missing 300 and 368 values. So these two individual columns. Okay. You first take a look at what additional info contains, then visualize the price of plane tickets by different airlines. Okay, so we need to take a look at what the additional info column is containing. Then we're going to look at the prices of those that additional info is giving us. So what is it giving us in the first place? Let's go back a little bit. So it's saying no info, no info most of the time here, as you can see right here. It's saying no info, no info, no info. Okay, let's see what we can do with that information. The following import have been made for you. Check the values for additional info column. Okay, how do we do that? Sorry about that. So print the values of additional info column. Let's see. Oh, I need to mention the data frame. Planes, brackets. Okay, now let's see what this is giving us also. So the value that we have here most of the time is no info, no check-in in bag included. So this is saying in-flight meal not include. Okay, some of the requirements to board the flights, probably you're not supposed to bring in your check-in bag. You're not supposed to have in-flight meal and so on like that. Okay, so those are the kind of information we have in there. But those are actually text or categorical information of for data type. Let's see. Oh, it said the values and counts. Let's see. What is the value count? Okay, dot value count. We should count the number of occurrence of those information. Okay. Okay, now for this content now, it's going to know the number of times this information appears in the column. More interesting. Let's see. So we know that we have this kind of contents or information or text in that column. We want to count the number of times each of them actually occur. And see no information over 6,000 times. In-flight meal not included over 1,000 times. No check-in bag included. One long layover. Change airports. No info. No info. This should be the same thing. I don't know why it's kind of different. Probably for different. No info. Business class. Red eye flights. Too long layover. Okay, interesting. So now we know the count of content in the additional info column. So what can we do with it? Create a box plot of price versus airline. Just a second, real quick. So I'm just going to have a couple of water. I have to have some water rather, so I can stop this cough I'm having. So now what we need to do is create a box plot of price versus airline. Interesting. A box plot of price versus airline. Okay. That should be XNS dot box plots. Box plots. Our data is the plain data set. Plain data set. Then our column that I want to visualize against each other is the airline price column and the airline column. Let's see. Interesting. Okay, let me just copy this. So what can we do with this information? So dealing with missing data is kind of messy also. It takes a while. Now we have the information of price versus the airline. So the Jet Airways airline, the Indigo, SpiceJet, multiple carriers. You can see the prices. Jet Airways is kind of high on the high side. Let's move on. Airline. Hmm. Sorry, the airline is supposed to be on the axis. And the price on the y axis. Oh, risky open this error. Airline and price. Exactly. Why am I getting an error now? What's the price for y? Let's see. Mm. Let's copy this in. Probably I'm making some mistakes somewhere. Okay, better. Let's see it better in this instance there. So I'm curious, what is the difference between the first and the second one? Aha, voila. I see the price is supposed to be on this axis, while the text is also on the axis there. Because the Jet Airways, you see, they are showing the same thing, just vertical and horizontal. Okay. Now, okay, it says, how should you deal with missing value in additional info and price? Hmm. So the missing values in additional info. So this is the missing values in price, and this is the missing value in additional info. So how do we deal with this? Okay, let's see. It says remove the additional info column and impute the mean for missing value of price. Okay, that could still work. Remove no info values from additional info and input the median of missing value of price. Remove the additional info column and input the mean by airline for missing value of price. Remove the additional info column and input the median by airline. I also want to use the median and mean. It probably want to use the median. But we can remove the additional info column since the information there is not doing much good to the analysis. So you can just go to the median airline for missing value by price. So the median price per airline. Let's go for this. Correct. So excellent. You do not need additional info column and should input median price by airline to accurately represent the data. So if you are going to do the median price by airline, that will give us the median value for the different airline prices that we have here. You can see based on the overall data set that we have there. So if you continue, let's see, let's continue. Just ignore this. Input missing values, plane prices. We want to try to complete this lesson today. Let's give it a shot. So now there's just one column with missing values left. You've removed additional info column on planes. The last step is to input the missing data in the price column of the data set. As a reminder, you generated this box plot, which suggested that inputting the median price on the airline is a solid approach. Okay, group planes by airline and calculate the median price. So to group planes by airline, so that we're going to use the group by function. Want to group it by the airline column. By the airline column. Then we're going to group it by the price column. We're grouping by airline and looking at the information by the price column to get the median. So that will give us, then we look at the median by each airline. Median. Okay, now let's run the code and see. Uh-oh. Airline prices, cost of planes, go by this column, dot median. Let's get up on the error. Group. Oh, I'm missing a P here. Group by. Oh, voila. So these are the prices for each, the median prices for each airline based on the data set that we have there so far. So I see the median price for Asia Air, India Air, Go Air, Indigo, and so on. So we're just going to input these values into those missing data, which is just less than 300, just above 300, which is a good way to represent the missing data. Convert the group median price into a dictionary. Okay, I'm going to convert this into a dictionary. How do we do that? Price dictionary. Mm. And let's use airline prices to dict. Let's see if that is going to work. So price dictionary is going to be the airline prices dot to underscore dict. Mm, let's submit and see. So that's how you do that. Let me just copy this, convert them to a dictionary. Let's do that. Use it to dict method. You can see if I say price to dict, price this dict, or I call on this so you can see the information that we have here. So actually what we have here, the Asia airline, Air Asia is the key value pair. So that I convert something to dict, a data frame to dict. So the next thing is to now insert conditionally input missing values for price by mapping values in the airline column based on price dict. Check for remaining missing values. Now let's input this information into our missing value column. It's going to be planes, the price column. Then I'm going to mention the data frame one more time. I'm going to say the price column one more time. I point to the price column. price column dot fill NA. That is the fill NA method. Fill the plains data frame. The price column. The price column using the mapping dot mapping map just map rather, not mapping map based on the price to predict information that we are there. Price predict information. Let's print our planes now. Check for missing values. Just check for missing values one more time in this instance. Just want to copy this information here. Let's check for missing values one last time. Ooh, there's an error somewhere. Let's get help for the error. Okay, I'm using the lowercase p here. Oh, my bad. The correct column is with capital letter. Voila. Hmm. Why we not having missing value? I'm supposed to be having missing value here again. Let's try to submit and see if we're actually correct. Airline column. There's a mistake somewhere. So I'm mapping the finale plane on the airline column. Okay. I didn't use the airline column there. Let's run the code again. Voila. So I'm just using my airline column here for my result to be truthful. Interesting. Now let's check. Let's check this out. Voila. So let's replicate the same thing in my Jupyter notebook here. I run this code, shouldn't get any error. Let's check for missing values. Ooh, okay. I haven't even removed additional info. How do I remove the column? How do I remove that column? I could do that. Let's remove the column all the way probably from here. Let's get rid of that column. Let's do justice by removing that column, that additional info column from our data sets. We can always complete our analysis pretty fine. And let's continue. Ooh, interesting. So we've learned how to deal with missing values and replace missing values in Python. Interesting. Let's get rid of our additional info column in this instance. I'm going to use the drop column method. I'm going to be remove additional info column. Remove additional info column. We're going to use the data frame, planes, and go to planes dot drop. So the column we want to drop is going to be equal to the additional info column. So we drop the additional info column just like that. So if we print this line of code again, we don't have the additional info column again. Interesting. So let's move on to the next lesson, converting and analyzing categorical data in Python. So let's see what we can learn here also.
Now let's explore how to create and analyze categorical data. Recall that we can use the select dtypes method to filter any non-numeric data. Chaining.head allows us to preview these columns in our salaries data frame, showing columns such as designation, experience, employment status, and company size. Let's examine frequency of values in the designation column. The output is truncated by pandas automatically since there are so many different job titles. We can count how many unique job titles there are using pandas .nUnique method. There are 50 in total. However, the fifth most popular job title, Research Scientist, appears less than 20 times. The current format of the data limits our ability to generate insights. We can use the pandas series.string.contains method, which allows us to search a column for a specific string or multiple strings. Say we want to know which job titles have scientist in them. We use the string.contains method on the designation column, passing the word scientist. This returns true or false values, depending on whether the row contains this word. What if we want to filter for rows containing one or more phrases? Say we want to find job titles containing either machine learning or AI. We use the string.contains method again, but this time we include a pipe between our two phrases. This will return true if an observation in the designation column contains machine learning or AI, or false if neither of these phrases are present. Notice that we avoid spaces before or after the pipe. If we included spaces, then string.contains will only capture values that have a space, which isn't necessary for us in this case. Again, we are returned the Boolean results. What if we wanted to filter for job titles that start with a specific phrase, such as data? We use the same string.contains method and include the caret symbol to indicate we are looking for this match at the start of the line. This will match titles such as data scientist, but not big data engineer. Now we have a sense of how this method works. Let's define a list of job titles we want to find. We start by creating a list with the different categories of data roles, which will become the values of a new column in our data frame. We then need to create variables containing our filters. We will look for data scientist or NLP for data science roles. We'll use analyst or analytics for data analyst roles. We repeat this for data engineer, machine learning engineer, managerial, and consultant roles. The next step is to create a list with our range of conditions for the string.contains method. We add data science, data analyst, data engineer, and all remaining roles, remembering to close our list. Finally, we can create our new job category column by using NumPy's .select function. It takes a list of conditions as the first argument, followed by a list of arrays to search for the conditions in. By using an argument called default, we tell NumPy to assign other when a value in our conditions list is not found. Previewing the designation and our new job category columns, we can sense check the first 5 values. All looks good. With our new column, we can visualize how many jobs fall under each category. For this, we use Seaborn's count plot, passing our data frame to the data keyword argument and the job category column to X. We call plt.show to display the plot. We can see data science, engineer, and analyst roles are by far the most popular. There aren't many roles categorized as other, suggesting we captured the majority of our data roles appropriately. Now it's your turn to work with categorical data.
Okay, let's see how to work with categorical data. Just a quick break. Oh. Just taking a quick break. That is a lot of information to consume. All right, let's continue. So finding the number of unique values in a column, definitely. So you would like to practice some of the categorical data manipulation and analysis skills that you've just seen. To help identify which data could be reformed or extract value, to help identify which data could be reformatted to extract value, you are going to find out which non-numerical columns in the plains dataset have a large number of unique values. Pandas has been imported as PD and the dataset has been stored as plains. Let's give it a shot. Filter the data frame for object columns. So I want to filter the plains data frame for columns that are of object data type. Okay, interesting. So we're going to say non-numerical data sets is going to be equal to plains dot select data types, select underscore d types, then you call on the object keyword here, objects keyword. So loop two for columns for dash in non-numeric. Okay, now let's see this in my Jupyter notebook. Non-numeric, let's see. Oh, mm, oh, select the types. I got the wrong information there. So we select the types. If I click on the non-numeric column now, let's see. Mm. So these are only the columns that are non-numeric. You can see. We say dot head. Interesting. Voila. You can see those columns that do not contain numbers. If you come up here a little bit, all the way from here, I will only have one column that really which is the price column. 2, 3, 4, 6, 7, 8. If I scroll down, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you understand where we're going, right? We have seen the columns that are non-numerical. So loop two columns. Loop two columns for what? Let's see. Loop two columns for dash in non-numeric dot value count. Print number of unique values. Prints number of unique values in column non-numeric. Okay. Let's see what we can do here. Loop through the columns in the data set, add the column iterator to the print statement, then call the function to return the number of unique values in the column. Okay, let's see. Then for columns in non-numeric, then for calls in non-numeric dot columns. Okay. So print number of unique values in calls in call this column non-numeric. Okay, hold on. Non-numeric, then the call column again. The call column dots n unique. You see the n unique from here. Dot n unique. N unique. Let's see. Okay. Voila. You see the number of unique values. Okay. Let me just copy this and give it a shot here. So you can see it better. So loop two columns for call in non-numeric dot columns from here. Print the number of unique columns in each column. Okay. Let's see. So number of unique values in airline column, which is 8. Number of unique values in the date of journey column. So it is giving us the number of unique values in each column rather is 44. In source column is 6 and so on. Interesting. So this line of code is going to loop through each column in non-numeric, which is this non-numeric dot columns. Then you're going to print out this information. Number of unique values in columns, name of the column, then non-unique value, non-numeric dot call dot n unique to give us the number of unique values in each column. Basically, that is what the line of code is doing. Uh-oh, mistake. We just paste it here. Oh, I did a mistake there. Let me just go back and copy this. Oh, why now? For calls in columns. Oh, is missing information from up there. Let's do it better. Then this information that we have here. Voila. So let's submit this. Great looping interestingly. So duration is currently an object column, whereas it should be a numeric column and has 360 unique values. Let's find out more about this column. Oh, duration is currently an object. We didn't pay attention to that. Okay, let's see. The duration column is currently the data type 4. Let's see duration. Duration is right here. Probably because of the age and m, it's seeing it as an object column instead of a numeric column. Okay, interesting. I currently have over 300 unique values. Okay. Flight duration categories. As you saw, there are 362 unique values in the duration column of planes. Calling plane duration.head, we see the following values. Okay. Looks like this won't be simple to convert to numbers. However, you could categorize flights by duration and examine the frequency of different flight lengths. You create a duration category column in the planes data frame. Before you can do this, you will need to create a list of the values you would like to insert in the data frame, followed by the existing values that this should be created from. Okay, create a list of categories containing short haul, medium, and long haul. Oh, let's have to create a list of categories for short haul. Flight categories. Okay, it's going to be a list, right? Okay, interesting. Spend an hour here. It's going to be a list, which is this string. So we're going to have short or long or. Let me just copy this real quick. Okay, short or long or. So short or long or list created. Okay, interesting. Oh, okay. I've run the line of code. I wanted to copy. I want to copy this and just find it so that I can understand what I was doing in that instance here. Hold on a minute. There. So we've created our lists. I just need to attend to a call there. We have this information broken down. Okay, now we've done this just for me to just know what I was doing. So we've created our list. Let me quickly reply to a message real quick. So create a list of categories. We've done that. Sorry about that. Now create short flights, a string to capture value of 0 hour, 1 hour, 2 hour, 3 hour, or 4 hour, taking care to avoid values such as 10 hour. Create medium flights to capture values nine between 5 and 9 hours. Create a long flight to capture any value from 10 hours to 16 hours inclusively. Okay. Create short values. That's going to be between 1 hour, between 0 hour to 4 hours. Okay. Okay, now I want to create value for these hours. Just taking, making sure. Making sure we are on track. Okay, let's continue. So create short all values. So fly between these hours. There's going to be this value. Let's see, put this value 0 to 4 hours. That's the information that we have. We create a short flight of a string capture values from 0 to 4. Okay. Okay. Okay, let's go on. How about this for this? For this, we have this. Let's see if you're actually correct. Okay, let's submit and see first. Oh, okay, let's get help. Hmm. Have you considered using the carat symbol to ensure that the pattern matches the start of a string? This will help you avoid matching unintended value like 10 when you are working with 0h. Okay, So with short flights, okay, let's copy this for short flights. Mm, okay, we're having the same result, but we want to be sure if we are correct by submitting the results. Oh, medium flights, so we're definitely not correct there. For medium flights, let's see. Are we currently using the symbol to ensure that the pattern? I'm having the same result for. Uh-oh. Let's use another pattern then. Okay. Let's see if this is going to work. Okay. Uh-oh. So we're having challenges in this instance. All right. So let's focus on the answer here. Short flights, medium flights. It's only returning for short flights, not medium flights. They say the medium flight is incorrect. And for medium flight is medium flight account between 5 and 9 hours. 5 and 9 hours. Okay, let me do something similar to what was done here. Five between 5 and 9 hours. So I say I'm not using the correct pipe for medium flights. This is 0 hour or 1 hour or 2 hour or 3 hour or 4 hour. But between 5 and 9 hours, it should be the same thing though. Okay, let's see this. Oh, so that is similar to what I wanted to do here. 0, 1, 2, 3. So I'm supposed to list 5, 6, 7, 8, 9. Then for 10, 10, 11, 12, 13, 14, 15, 16. Come on. Okay, let's accept that. So that I create the flights information. So create flights, short flight, medium flight, and long flights. Okay, so let's submit. So now it's done. Now you've created your categories and valid. It's time to conditionally add the categories into a data frame. Okay. Let me just quickly check something real quick. So now, next challenge is to adding duration categories. To add these duration categories to our data frame, I probably need to stop there. Let's continue first. Create conditions for values in flight category to be created conditions. Planes dot the category. Okay. Create conditions a list containing subset of plane duration based on short flights, medium flight, and long flights. Okay. Create the category column by calling a function that accepts your conditions list and flight categories, setting values not found to extreme duration. Create a plot showing the count of each category. Oh, okay, okay. Let's complete this. Let's go. Let me just go back a little bit here. So the first instruction now says create conditions a list containing subset of planes duration based on short flights. So this will be plane duration. Okay. Duration. Oh yeah. Duration. Duration. For the string, that should be str. 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 That contains, we want to contain the keywords that contains the keyword short flight, medium flight, and long flight. Okay. Contains it'll be for the medium flight, the short flights now from our short flights, short flights, medium flights, and long flights. Then create a duration category column by calling a function that accepts your condition list and flight category, setting values not found to extreme condition. Oh, so if it's value not found, we just set it to extreme condition, yeah? Maybe that's traveling to Asia or probably China or the Pacific. Okay, now. So this is going to be apply the condition list to the flight categories, planes duration category from here equals to np.select, np.select conditions, conditions from above, flight categories. Depending on the flight categories. Okay. And finally, we print the box plots, the count plot, plus the count of each category, which is going to be count plots. The data is going to be our plain data sets, and our category is just going to be the duration category that we have here. So our duration category, duration underscore duration. Duration. Let's run the code. Voila. Ooh. Estimate duration category. Hold on a minute. If we try to submit this, let's see what we have here. There's definitely an error somewhere. Check or check your call of plain the string contains. Did you correctly specify the first argument expected? Okay, let's get help for short flights. Okay, we're supposed to use the variable directly, not with the quotes. Oh, that was a mistake we did there. Many long flights. Let's run the code again. And voila, we have our results here. Interesting. Let's see it in action here. This is a long haul, definitely a long haul. Okay, create a condition for values in flight category to be created. Okay, so this is the condition. Next is to apply the condition list to the flight category. Then finally, we print the value out to see. And voila. So you can see the extreme duration that doesn't fall between medium, short, or long haul. Those flights that fell off this category. Wow. Creative category transformation work. It is clear that the majority of flights are short or yeah, and virtually none are longer than 16 hours. Now let's take a deep dive into working with numerical data. Ooh, so we're going to stop here for today. Probably come on live in the evening or in probably 6 hours time and complete this working with numerical data so you can complete this lesson very quick. All right, so that'll be in the live stream for today. If you enjoyed this learning journey with me, or actually messing and dealing with missing data sets, creating new categories, and actually visualizing some little inside there, do want to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel. Bye for now. Have a wonderful rest of the day. Voila.